Welcome back to Let Us Learn to Lead video series on free open source software prepared by M. Srinivasan, Training Associate Mathematics, Kendriya Vidyalaya Sangathan, Zonal Institute of Education and Training, Mumbai. Self-learning contents in video form on GeoGebra. Dynamic mathematics software is presented at this video series. To view the contents, you may join Google Classroom by using the class code 73AUMBO. In this video, you will learn designing worksheet to construct Isosceles Trapezium and check its properties. For preparing this video lecture, I used Windows 10 operating system, a licensed version, GeoGebra 5.0, a free open source software, and free open source screen recorder software. Let us start. Let me show you what type of worksheet we are going to prepare. We are going to tell what is Isosceles Trapezium. It is a trapezium in which the non-parallel sides are equal in measure. For doing it, we are taking a trapezium with some measure. AB 11, DC 7, AD, BC is equal to 6 centimeter. We will construct it. Okay. Then we will tell the properties one after the other. That is, non-parallel sides are equal in measure, diagonals are equal in measure, the base angles are equal in measure, and the opposite angles are supplementary. Now here the thing is, this particular trapezium cannot be moved and shown because we have constructed it with a selected fixed measure. That is, AB, DC and AB are fixed over here, but they can check it about the property of the non-parallel sides, the diagonals, the base angles and the opposite angles. Let us try to construct it from scratch. I have taken GeoGebra Classic 5 worksheet, geometry. I have selected the view. In option, rounding off to one decimal place you can have. Then in labeling, new points only. We will have a heading for this. Isosceles Trapezium. I think we have already discussed. It is always better to have this navigation bar so that you can just show step by step to the children. Well, now we will just explain to the children what is Isosceles Trapezium. You can ask them what they mean by isosceles triangle. Then you can go to Isosceles Trapezium. Very interesting one. Isosceles Trapezium. We have made it. For that, I think we can construct a very general isosceles trapezium. But for the time being, let us try to have a trapezium ABCD by taking like this, AB parallel to CD. And let us have some measures which tells that the non-parallel sides are equal. For AD and BC are non-parallel sides because AB and CD are parallel. For the other two sides will become automatically non-parallel. Therefore, we are taking the non-parallel sides as equal. Okay, let us start. For that, first we will go for the line segment with the given length. You touch it. It will ask what is the length. AB is 11. Therefore, I am taking 11. Escape so that you can bring it A at the bottom, B at the bottom. Now, I want to take a point which is 7 centimeter away from A. For that, normally we will do arc. But here the arc is not there. For circle with center and radius, we will put it over here and we will type 7. We will just touch at a point now. We will take this point of intersection. The point of intersection. I'll touch this and then touch this. You got this point of intersection now. Okay, now this point is actually C, but we don't want it to be C. Let us see. Okay, now we are having in our this one that BC is equal to 6 centimeter. Therefore, this is not C. Be careful with that. This is not C. Okay, we are going to see later. Otherwise, if you want to rename it, you rename it as E now itself. Okay, A, B, C, D we want. Okay, well, now we will take the circle with center and radius. We will take a circle centered at E, which is of 6 centimeter, because you have been given BC as 6 centimeter. Once again, with B as the center, let us have another one as 6 centimeter. Both of them meet at a point. Well, let us go for this point of intersection. These two. Okay, they have it at D, but I don't want it as D. I will rename it as C. Now I don't want these circles which will be disturbing me. Therefore, right click it and then show the object. Right click it and show the object. After the job is over, you can hide it. If you want, you can bring it back. This E also I don't want, for I am hiding it. Okay. Well, now it is given that D is equal to 6 centimeter and DC is equal to 7 centimeter. Well, let us go for it now. Let us again go for the circle with center and radius. AD is equal to 6 centimeter, or with A as a center, 6 centimeter. Well, DC is equal to 7 centimeter with this as the center, again as 7 centimeter. Okay. Oh, they are meeting at a point. Go to this point of intersection. Touch these two circles. They automatically meet at D and F. Well, I don't want this escape. I don't want this circle, therefore show the object. I don't want this circle even, therefore show the object. This F I don't want, therefore show the object. ABCD you got now. Now go to this polygon. Touch this A. Touch this B. Touch this C. Touch this D. Touch that A. Well, good. Now remember, ABCD is you got, but you cannot move anything over here. You can only simply rotate it because this particular trapezium has been constructed by you with the given measure. Okay, now what are the first property? Non-parallel sides equal. That is why it is a trapezium, isosceles trapezium. Let us try to visualize it. Escape. Select this AD, right click, go to this object property. In that object property, you show its value 6. Again, carefully touch it. I think the polygon is selected for escape. Polygon should not be selected. You have to select only this segment. Segment is selected. Go to the object properties and then go for its value. Now both are coming as 6 and 6. Okay, well. Now the next property. Now I think you can write it over here. I think I will write only one and then you can write it in the AD is equal to BC is equal to 6. Okay, well. Now what is the next property is actually the diagonals are equal. Okay, let us check the diagonals. It is a special property of isosceles trapezium. Okay, what is the meaning of it? You have to tell that AC should be equal to BD. Well, let us see. Let us see whether it is equal now. Okay, let us take this segment AC and then segment BD. Good. Let us try to get their escape. Let us touch it and then it is getting highlighted. Go for this object property and in show label you go for its value. Oh, 10.6. Go to the second one. Once again go for its value and then go for its value. Oh, this is also 10.6. Therefore the diagonals are equal. Now let us see what is the property of the angles. For the angles it is very simple. You escape. Okay, you go to this angle and then simply touch it. Now all the 4 angles you have got. Now you ask the children that actually these 4 angles I have got now. What you can infer from this? What they can infer? Now this angle A and angle B are equal. What is the meaning of it? The adjacent angle are equal. The base angles are equal. Now another one is that suppose if they are adding the opposite angle 70.5 plus 109.5, what will happen to it? When they add it, then they will get 180 degrees. Okay, this is the way that the child can tell about its angles. Therefore, you can tell them that what are the base angles, what is the speciality of the base angles, and what is the speciality of the opposite angles. For when they add the opposite angles, actually what happens to it. For now, you can ask the children these 2 questions about base angles. Okay, now let them come out with the answer. Now again you can ask them, what about opposite angles? Okay, if they construct any isosceles trapezium, these properties will hold good. What are the properties? Number one, the non-parallel sides are equal in length, therefore it is isosceles. Number two, diagonals are equal in length. Number three, there is a property about the base angles, they are equal, and the opposite angles are, when you add it, you will get 180 degrees. For now, a child can understand the difference between a trapezium and an isosceles trapezium. Thank you. Let us learn to lead.